It's the desk of Lady Ada Pi Hack Ada Edition with Hackaday.io and Adafruit. And here's Lady Ada.
Yay! Yay! All right, thank you so much, radio announcer Phil, for introducing me. Yes, tonight we're going to do another PiZero contest video. So we're going to be talking about the PiZero. It's a $5 Linux computer. It's a Raspberry Pi. Has the same base computational power as the Pi 1 Model B, but it's a lot smaller, skinnier, chewable, and you may want one. And so do about like 50 or 60,000 other people. There's not a lot of PiZeros available. We saved 10 for you, and you, and you, and you, and you, and 9 other people. If you would like to win one of these 10 free Raspberry Pi Zeros, it's super easy. All you have to do is enter in the Hackaday.io contest, which is what we're going to be talking about. It's a contest run by Hackaday.io, which is a free project blogging site. You can go there, publish an idea for a Raspberry Pi Zero. You don't have to have one for the publication. Theorize, conceptualize, draw. Check out, there's like 100 entries with ideas. Look at them and maybe get inspired for a project. Document what your project might be, prototype it with any hardware or 3D modeling you want. And then on February 25th, the judges of the Hackaday.io contest will pick the 10 most thought out, best documented projects and send those 10 people a free Raspberry Pi Zero. And then you can keep working on your project, and 2 weeks later, on March 14th, I can't remember the date, you can, your final project gets entered into the contest, and the winner, there's 3 winners, each one wins a $100 gift certificate in the Hackaday store, and you can still enter your project into the Hackaday Prize, the 2016 Go to Space contest. So you can win up to like 3 things. All you have to do is document a project on a free site. No purchase necessary. So very exciting. Thanks to Adam and Sophie for putting this together. We've had fun. We're doing 10 videos about the Raspberry Pi Zero. Check them out. We've already done 7. If you're interested in how to add video or sound or analog inputs or digital GPIO or 3D rendering or whatever to Raspberry Pi, we've covered a lot of that stuff already. And then tonight we're going to talk about, I'm going to actually kind of build a little bit of a project because we've done so much basics. We're going to show how to control NeoPixels. Pretty straightforward. I'm going to download the library, install software, and I'm going to show you some just tips and tricks for doing that. And then I'm going to actually try to send and receive color data from, send sensor data and receive color data using Adafruit.io. So I'm going to basically show how you can use a REST interface, the REST interface software we have for Adafruit.io to send and receive data. You can prototype it with one of many dozens of MQTT or REST data brokers, but just to give you an idea of how you can build an Internet of Things thing using your PiZero. Okay, did I cover everything?
Yeah.
Okay.
Tonight, instead of scope cam, though, I just want to point out that we do have quad cam. However, there is...
I'm not using the scope tonight. We don't need the scope.
However, there is an issue with it, and the issue is there's a cat.
So, he turned around. So now
he turned around.
It's kind of cat butt.
What's funny is MOSFET is, I think, old enough to know that there's a camera on him, and so he turns away from it. For some reason, he knows that there's a camera on him.
Yeah.
Yeah.
Yeah, it's still kind of cute. He's just sitting on the
Anyways. Okay, so what do you want to go to first?
Let's go to my screen, my computer screen, and we're just going to, here's the contest. So if you would like to enter, go to Hackaday.io contest 9326. The contest is running through March 14th, so you still have a whole month. Can you imagine we've only been doing these videos for 2 weeks? It seems like forever, but it's only in the first third of the contest. You have tons of time to enter and do something awesome. So I'm actually going to kind of cover just doing NeoPixels on a Raspberry Pi. NeoPixels is just our name for WS28101 or 2812 or compatible. There's actually a ton of chips now that are all under that same protocol. SK6812, APA104, WS2812, WS2812B. So they're all called NeoPixel, and so the libraries often refer to them as NeoPixel because again the part number is going to vary. But they all kind of look like this, and they look like this. They come in strips and rings, and they're kind of available everywhere. There's a NeoPixel Shield Shield hat made by PiMoroni as well. And but it's pretty straightforward. There's a really nice library that uses because it needs specific timing. You can't just use any GPIO. What this does is it uses the DMA output of the PWM library to shape the waveform, and so it's a little bit of a cheat. It just means you have to use pin 18, but no biggie. I mean, like, if you want to have audio, you can use one of the other audio methods to get audio out. Or you can also use the other PWM channel. Because remember, you have two PWM channels. 0 and 1. So we're going to be using pin 18. We have this great tutorial. It's pretty straightforward. Actually, you just have to wire it up. There's only a little bit of a trickery with the voltage, and you may not need to do this, but it's just a good warning. The logic level for the the logic level for the Pi is 3.3 volts, and NeoPixels want 5 volt logic and 5 volt power. And you can actually do 5 volt logic and 3 volt power. 5 volt power and 3 volt logic. However, if your 5 volt line is a little high, look, it's kind of closer to 5.5 or 5.8 volts because you have a power supply that just gives you a little bit more headroom. You might need to use a level shifter, in which case we suggest something like a 74AHCT 125. Anything with the 74 HCT series will convert as low as 1.5 volt logic level to 5 volts. So you can use that. Another thing you can do is use a diode. So this is a logic level shifter. So you can do that to convert the 3 volt level to 5 volt level. You can also use a diode. I mean, this is kind of a little bit of a cheat, but it works pretty well. If you have a 5 volt supply that's a little high, you just put a 1N4001 in series. Remember to use a power diode. So 1N4000X series. Don't use a 1N4148. They're only good for about 100 milliamps or so. I don't know. Check the data sheet, but it's not going to be an amp. These can do an amp, and then they can spike a little bit higher. So this will give you a 0.7 volt drop. Kind of handy just for kicking down the voltage. But actually, there's another thing you can do. If you have a small strip, like this is a little ring, you can actually power it from the 3.3 volt line. Just be aware that you don't want to load the 3 volt line too much. The PiZero has a buck converter that I think we looked it up once. It's like a 600 milliamp total buck converter, and about, let's see, voltage, how much current is taken up. It's about 250 milliamps is used by the Pi, so you can spare a couple milliamps for the NeoPixel ring. So that's what I'm going to be doing. I'm going to be just powering it from 3.3 volts and also giving it 3.3 volt logic. Again, under spec, but for this demo it works. Didn't want to spend time to wire up all this gobbledygook. Want to get straight to it. Okay, so installing the software is pretty easy. I'll go through it again. So to here, let me shove over this. So you'll have to do your sudo apt-get update. Oh, you do have to have like Wi-Fi, of course. Get Wi-Fi. Hey, what? Are you positioning the cat?
I'm trying to have him behave reasonably.
And you can go to cat cam.
No, I don't think it's.
Yeah, why don't you just go to cat cam right now? Let's take advantage of this.
Yeah, I just
moment.
want to see how this worked out now.
Yeah, that's pretty good.
Right.
Hey, cat. He's alive. It's good.
Yeah, kind of boring.
Look.
Right, back to the action.
Okay, back to the action. So you have to install, a couple of Python dev things and Git, scons. I have never used scons. I have no idea what this is. It seems to be some sort of like pre-make configuration thing. I don't know. People love coming up with new ways to make tools that make tools that make tools. You can clone this. It's by Jay Garf. Thanks, Jay Garf, for writing this up. And then you run scons. Sconscript. Yeah, and maybe it's some make clone, like not clone, but competitor or something. Oh, weird. All right. Anyway, so it builds the C file, and then you have a Python library you can use as well, which is what we're going to be using. Swigging. Swig. All right. Okay, so we're going to wrap this up. And then we can go to examples. And we'll just run the strand test to start. You know, pin 18, frequency, we're going to use the 800 kilohertz DMA channel. So we use DMA to basically get the pin to clock up and down in the exact right way. Inversion, if you are using a MOSFET or an NPN transistor to level shift by inverting with like a pull-up resistor, you would use this. Doesn't matter, you know, it doesn't matter, you just invert all the signal exactly and then you invert it again. No, you don't have to. And then pin 18, and then the demo just runs, so let's do that. So before we run this, let's wire it up. Okay, so now we can actually go to quad cam. So this is good. Cat turned around, by the way, so I look. Maybe he doesn't like the light. Okay, so we have plug in ground first, always recommended, then power, and then signal. We have signal, and then I'm going to connect this to, hold on, 3.3 volt power. Okay, and then run this and like, whee, a little bright. Let me reduce the brightness a little bit. Super easy. And now we've got this strand test. Okay, so NeoPixels work. So if you don't want to do Internet of Things stuff, you can stop right here. You can turn off this broadcast. You now have NeoPixels, so you can pretty easily. He's gonna rotate the cat. I mean, he's gonna just get up and turn around. Thing is, you know, he's so black you can't really tell. It's kind of hard to tell. Only the nose. Hey. He doesn't like the camera. He's like, why is this thing staring at me? All right, so we've got this lovely NeoPixel. So that's part one. Okay, so NeoPixels work. So that's lovely. So the next part of the demo is I want to connect this to the internet, because having you know, color LEDs is one thing, but it's more important to have them connected to the internet. So I'm going to use Adafruit IO to do the connection, and I already, you know, there's color picker where you can check, you know, decide which color you want. And I'm also going to have it send data from the Raspberry Pi to Adafruit IO. And we did a video a couple of weeks ago. Wow, that's a close cat. Close cat's really close. We did a video a couple of weeks ago about MQTT, and I actually wanted to try a different thing. I'm going to use REST instead, because we have Python code for REST. So check out in our Git repository, we have IO client Python. So I already installed the software. Basically, you just run sudo pip install Adafruit IO, and then this will install for you the Adafruit IO Python library. I already had installed it because I was testing this earlier. So normally it would print a bunch of stuff, and it installs PAHO MQTT. And then we can check out the examples. So simple example. And we'll paste this here. And this is the REST client. So basically all you need is your Adafruit IO key. You can get that by you're making your account. Anyone can make an account. It's free. Grab your key, paste it in, and then you can send a value to a feed. So for example, I've got this feed which is called photocell. So I'll send the value 42, and then I will also send a something to text, which is another feed. I'll have it say hello world. And then I want to receive from this feed called on off. And then I'm also going to receive the most recent value from color, which is this color picker. Sudo Python simple. So as you can see, this got updated and it says 42. This says hello world. And, oh, we've actually got, oh, it says test. It got off from the on off button, but I think, did I? Let me save that, try again. It's weird that it would say black. It was black, but that was a while ago. Okay, now it works. So it got OC0C6FE5, so that's the hex value for the color that is displayed here. So this is just a very simple way to send and receive data. And this, you have a Wi-Fi connection on your Pi. I've just got a little Wi-Fi hub over here. But you can also tunnel this data, of course, over RF or Bluetooth to some other device that can do Wi-Fi. It's just a way to get to the internet without having to deal with firewalls, basically. And you don't have to know IP addresses because this is on audio.adafruit.com. I can pull out my phone and log into this and send and receive data from here as well. So now that I've got this up and running, I actually have, because I wanted to make this fast, I have my first example code. So what I did is I basically took that simple demo that I just showed you, and if you remember, yesterday we did a tutorial on analog reads, and I showed how you can read a photocell by doing an RC timing count on it to kind of measure the analog resistance without actually having to have an analog converter. So I just copied and pasted that in here, and then while true, so continue to loop, read the RC time constant value from pin 21, print the value, and then send that to photocell, which is my feed, and then sleep for, let's say, 2 seconds. I'll make this a little fast. And then I have to just wire up that same setup I had yesterday where we have a photocell from plus 3 volts to 21, and then I have a 1 microfarad capacitor from ground. So as this, what the pin does is it, you can check the video yesterday, but basically sets the pin low to empty out the voltage from the capacitor, and then has it as an input, makes the pin input so that the current flows from 3.3 volts into the capacitor, slowly charging it up, slowly charging it up. And then when it hits about 1.6 volts, that's the logic level, this pin reads as a pin high, and then it tells you how many ticks that took for it to fill up the capacitor. The smaller the resistance, the faster the capacitor. Higher resistance means less current is flowing, and so it takes a little longer. So it's simple timing. Of course, you can set up any sensor, I2C, analog converter, one wire, whatever, but kind of a nice, easy demo.
Want to answer a question?
Yeah, sure.
What thermo sensor is is usable to read basic human body temperature? I have an idea for a PiZero project and would like to use one.
Well, don't shove it up. No, what you can do to measure temperature is you can, we have a food safe 1-wire temperature sensor, so you could actually have somebody hold it in their mouth. I mean, the tough thing about getting human body temperature is you have to be inside the body. So, you can hack an ear thermometer. You could have them put this food safe thermometer and their temperature sensor in their mouth. It's uncomfortable, but that's a way to get temperature sensing from inside the body. A lot of people just use skin temperature and kind of just hope for the best.
All right. Ready for another question?
Tough, yeah.
Okay, this is not Pi related.
That's
but,
cool.
Could I maybe get some input at what I could be doing wrong? My ESP8266 without board, once they connect it to Wi-Fi, is there something I need to do to keep the connection alive that I might be missing?
Could be a power issue. I mean, the ESP takes up a lot of power and it has spikes. And if the voltage droops a little bit, it will possibly reset. Could be also your router is resetting it for some reason. You can't adjustment. I mean, I don't know. I mean, the fact that if it connects at all, it's kind of a good sign. But if it keeps getting kicked off, it sounds like either your router is upset or you're losing connection because of a power droop or something. So most likely, power issues are the most common issues with ESP8266. I see it a lot. A lot of people don't realize how much current it draws. It can easily spike a couple hundred milliamps.
It's like MOSFET has a compass in him, and he just will not face towards camera.
You know what? I think actually it's the light. I don't think he likes the light. You want me to move the light?
Which light?
This one, maybe.
It's facing the opposite direction.
It's not facing him, but
Yeah.
maybe he's.
No,
He's always kind of like faced away
he
from.
knows
camera.
there's a camera. He knows it.
Yeah.
I think cameras might emit some type of
Squeak.
squeak or loud noise in his cat brain.
Okay, or people enjoying cat cam.
Yeah, sure.
Good. I mean, it's tough with compete with Tony's Carmen. Carmen is like a super photogenic cat, like fluffy, like in a box.
Yeah. And now he knows we're talking about him, so it's all messed up.
Yeah, it's kind of weird.
Yeah.
He doesn't really do much more than this, by the way, people. Like this is what you get with the cat. So let's run this this program. So I'm printing out messages, and as you can see, hold on, the output is updating over here at the same time as I'm sending data from here, and then it updates every 2 seconds. So if I cover it up, the value goes high, so it's like it's really dark, and then it goes down again. Hold on. To like 200 or so, and then if I shine the NeoPixel on it, it'll probably get even lower. Oh wait, well, I don't want to, because I can't really do that. But like maybe I could do this. Yeah, so now it goes down to 100 because I just turned on this light. So this is an easy way to get sensor data. As you can see, it's like 30 lines of Python, and basically you just put in your key, and then you can send data every 2 seconds. I think the limit is like once a second or so, sending data from your Pi to a dashboard, and this is using REST. And so the next demo, REST photo color. So this is very similar, except I also then pasted in. I'm gonna make this less bright. See, maybe I'll make it 50. I pasted in the NeoPixel code as well. So now I've got that RC timing code for the photocell, but I've also added the color, this NeoPixel stuff, and added the function called color wipe that will fill in the entire ring. And so here's the photocell code. So just this is a technique. If you haven't written a lot of code and you want to pull together a project, I had the RC timing code working, I had the NeoPixel code working, right? So you have 3 separate things and you want to combine them. You get the REST thing working, and then you add just one element that you want to the REST interface code. So I had that, the REST interface was working with the demo. Okay, great. Now I added a loop and did the photocell timing. And now I'm like, okay, I want to add color feedback as well. Add that last. A lot of times I see, especially beginners, and they're just so enthusiastic and they really want to do this project, they'll just copy and paste like 18 different projects into one gigantic file, and then they'll get it to compile somehow, and like it doesn't work. It's like, well, it's not that simple. You really want to do piece by piece, so you make sure you understand every change you're making, and if you add only piece by piece, you'll know when one piece breaks the previous one. It'll help with debugging. Just a hint from seeing this over the years. So this is the RC time function. So this is the function that clocks and keeps track of the GPIO and how long it takes to charge up. And then I just have that Adafruit IO code. So I just kept that in there, except now, instead of just writing the data to photocell feed, I also read from Adafruit.io the color, which is this block here, and I print it out, and then I just unpack it from a hex value, because it's like hex red to 1 byte, green 1 byte, blue 1 byte. I unpack that into an array, and then I run the color wipe, which just displays the colors. And then I'll just change this to update every 2 seconds. So now we've got that same thing. It's writing values to Adafruit.io. Okay, so that's finally, we took a second there. Writing the value, updating, if I cover it up, it goes dark. If I move my hand, it goes back down. And then I can change the color by saving a new color to the color picker. So yellow, or maybe I want to do pink. And then it might take a second for the next time it looks up and then converts to pink. I could also turn it off by setting it to 0. Now the LEDs are off. I can set it back to red. Goes to red. So very easy sending and receiving data. You can use MQTT as well. MQTT has the benefit of being much faster, but it's a little bit more difficult because of callbacks. Nothing especially difficult about callbacks. It's just I think a lot of people are used to the ideas of polling, and if you don't need to have to the millisecond update, if you're okay with checking every 2 seconds, you make a connection, and especially if you have Wi-Fi where it doesn't you're battery and you're not battery powered, so it doesn't matter how much data you're sending and receiving. Doing stuff with REST is really, really easy compared to setting up an MQTT client. There's state and callbacks, and you have to have the connection and keep alive. So very easy demo, but just shows you how you could maybe add NeoPixels and make your PiZero project internet connected. It's the future.
Okay, this has been Desk of Lady Ada, PiHack 80 edition, the Hackaday.io contest that we're doing. We're giving away 10 Raspberry Pi Zeros in addition to a bunch of other stuff. Check out Hackaday.io and you will see all the entries. Oh yeah, oh boy.
What?
Well, this is why he doesn't ever want to be near a camera.
What? No.
That's our fault.
No, he loves this.
Yeah. So
everything's perfect.
Yeah. So,
don't worry. I mean, he's a tyrant anyways. He's in it.
Yeah. So you can check out Hackaday.io and
help.
and put up your project ideas, and you too can win a PiZero.
Not this one that's now
Cranky,
super static.
Cranky cat not included.
Yeah, there you go. Can you see that? That's nice. Yeah, there you go.
Yeah,
PiZero. This cat's free. We will throw in this cat for free. You have to take care of him.
Yeah.
All right. And thanks, everybody.
Okay, that's it. We'll see everyone on Ask an Engineer Wednesday at 8 p.m. Eastern Time.
We might do another video cast tomorrow.
Yeah.
You don't know.
Show and tell 7:30 Eastern Time.
3D Hangouts.
3D Hangouts on Thursday, and then we'll just keep doing these. Okay.
Keep rocking it up.
Thank you so much, folks.
Thanks, everybody. Say goodbye, MOSFET. Meh. He's not going anywhere.